I thought it might be a good idea to summarize, what happened over the course of the last year, especially with respect to the SARS-CoV-2 testing. And we're going to start with the pre-pandemic situation. This is a graph that Kobe prepared, I think, and it shows what the state of the art was, the typical workflow and workload that we received in the clinical laboratories prior to the pandemic. What you can see here is that the most frequently ordered tests, these are weekly volumes here on the left-hand side, was a CBC, closely followed by a number of routine tests that we do a lot of. Here was our total volume of molecular testing done in clinical chemistry and in micro. And of course, we had no COVID testing. This goes from July 10th of 2019 through the middle of February of 2020. So in order to bring in the SARS-CoV-2 PCR testing, which had emergency use authorization, what was required was a much more extensive validation than what we do for typical FDA cleared assays. And I'm just going to share two aspects of the studies that were done by Dr. Bogan back in March of 2020 on the M2000. The first was establishing the limit of detection. And in order to do that, we started with a SARS-CoV-2 standard, made a series of dilutions. There was a little recipe for it. This is actually from the one I did on the Alinity later in the year, but it was the same idea, to get a variety of concentrations of the SARS-CoV-2 virus. We started with 5,000. We made a 1:5 dilution, got it down to 1,000. And as you can see here, we got it all the way down to 8 copies. And then we measured each of these specimens on the M2000. And what you can see here is that as the concentration decreased, the blue dots are the first cycle number, the orange dots are the second cycle number, signal off the instrument. You can see as the concentration went down, the cycle number went up, and that's something we'll see continuously. But we still could detect concentrations down to 8 copies per ml. So that's an extremely sensitive test. The FDA clearance, the Abbott claim was 100 copies, which is also a really sensitive test. And then the second aspect I want to show you is a very important aspect, and that is confirming the clinical or diagnostic sensitivity and specificity. The FDA guidance says that you need to test a minimum of 30 contrived samples and 30 non-reactive samples. These contrived samples are samples that are negative that you spike with RNA or inactivated virus. And they tell you that you should, this is very important, you can't just spike them with huge amounts of virus, but you need to do a clinically relevant amount of virus, which is 1 to 2 times the limit of detection that you're claiming. So that's what we did. And here were the specimens that were done. To check for non-reactive specimens, there were 60 normal, healthy staff, volunteers. One test was repeated twice because it was, we got no amplification. There's an internal control on every one of these specimens when we run it. We tested oropharyngeal specimens as well. And we did have one surprise, an asymptomatic laboratory staff member was positive, and it was deemed that that was a true positive. But, it was a way of documenting that the test worked and that we were running it correctly. These are things you don't need to do usually with FDA cleared tests, but this was EUA. For people who aren't familiar with it, I just wanted to briefly talk about the principles of PCR. This isn't quite as nice a slide as the one that Ulrike showed us a couple of Wednesdays ago, but you start with a DNA template of interest. You denature the DNA into 2 separate strands. You have primers. I'm going to close the door because I'm too loud. For specific areas of interest in the DNA. And then the reagents are in place to extend those areas of interest, and you get 2 more copies. And then you do that with a second and a third cycle and so forth. And you end up with, millions upon millions of copies of the DNA region of interest, or in this case, RNA region of interest for your assay. So the version that we run is a quantitative real-time PCR. And if we add one or more labeled complementary oligonucleotides to the region of interest, we can watch the accumulation of signal over time. As these cycles occur, more and more of the regions of interest are being amplified, and therefore more and more color is being generated. And at a certain threshold, the reaction is deemed to be positive for a qualitative test. And if it's quantitative, you can estimate the actual concentration. And the software in our instruments takes into account the shape of the curve, the time to the threshold, et cetera. And of particular importance, if you have multiple different labels, different colors of labels for your complementary oligonucleotides, you can detect multiple targets. So those targets can be different organisms, or they can be different gene segments on a single organism. For SARS-CoV-2, if any of the targets light up, and most of these assays have 2 targets or 3 targets, but if any one lights up, it's considered a positive reaction. Here's a diagram of what a typical quantitative PCR looks like. These are the cycle numbers. And again, if the amplification occurs early on, because it reaches a threshold of many copies early on, that represents a high concentration. And as you proceed along here, this has the highest concentration of target RNA. This has, or DNA, a little bit more, a little bit more, a little bit more. As the cycle number increases, the concentration that you started with was lower. So just get used to that. A lower cycle number indicates a higher initial target concentration. So that's the basic principle. We had a lot of people helping out with this over the course of the year, and a couple of them that I want to talk about here were the IT solutions that were developed that enabled us to do things. So our friend Kristen, who's now at EPIC training and is EPIC certified, figured out this incredibly ingenious way of allowing tests from different workstations to be tracked independently and yet to be mapped to the same final result in Saurian. So we had the flexibility of using multiple different instruments for the same test ultimately, and we could track them by instrument. But in the end, the results would go to the same field in Saurian, so that the physicians could monitor just a single result field and know whether it was positive or negative. This was an amazing accomplishment because it made our job so much easier and gave us the flexibility to add other instruments as things proceeded. We had the M2000, we had the Panther, we had the Cepheid, we later added the Liat and the Alinity M. We can do tests on any one of these instruments as dictated by workflow, reagent availability, and all the other infrastructure we had was able to make use of the positive or negative result. The other thing I wanted to highlight was this thing that most of us may not have seen, but Kobe and Nick created a series of statistical reports that were generated daily using data from SOFT. Nick circulated these reports every morning to the Tufts Medical Center leadership to provide the status of testing. Here's a sample from November, December. The columns in blue are the testing done here at Tufts, from Tufts. It's all testing at Tufts. The orange was testing we were doing for Lowell General and other well-forced people because they couldn't get reagents or enough reagents to do their own testing. And the peaks here are the highest volumes we were doing. These other lines here are the 7-day rolling averages. This blue line is the 7-day positivity rolling average for Tufts Medical Center. And here is the rolling average in orange for Wellforce. And you can see over time, those averages changed. And at the end of December and early January, we were really getting hit with a lot of positives plus a lot of volume. We were doing 1,200 tests a day. I mean, it was pretty incredible. We also published a paper with a lot of help from a lot of people listed here as co-authors, comparing the sensitivities of the different assays. So remember, all of the assays just report positive or negative, but they don't all have the same limit of detection. And so what we did, we compared samples, clinical samples, across multiple platforms to see what the detection rate was in real clinical samples. That's because different people use different standards to establish their limit of detection. And they may not be like the matrix of a true sample. So by doing this, we get an idea of the performance in real specimens. And what we determined was that in this comparison, the M2000 was the most sensitive. We knew that going in. And we compared to that the Gene Expert, the Cepheid assay, and the Luminex assay, the Ares assay. And what we found was that 27% over all of the samples we were testing were positive. If we used, instead of the Abbott M2000, we would detect copies, instead of down to 10, down to 100 for the Cepheid. Cepheid would detect all but 4% of those specimens. It would miss some very low concentration specimens. But the Luminex assay missed 27% of specimens. And so even though we validated that assay in microbiology, we never used it because we felt it would miss too many patients. So this was published in the Journal of Applied Laboratory Medicine late this fall. And I thank all the co-authors here for that. Moving along, we had steady volume increases. As you can see, now I filled out this graph a little more. The COVID testing went up in the end of March 21st, 2nd, 3rd, somewhere in there, and the volume started increasing and increased rapidly. We started on an M2000 that we had here for doing certain tests in the molecular lab in chemistry. We added the SARS-CoV-2 testing to that. We knew we would need a second one pretty early on, and we got one. And so we added the second M2000 here as we were peaking. We added the Cepheid for rapid turnaround time. This was in late April. We added the Panther, another high throughput instrument, in July, but this volume, as you can see now, remember, these are our CBCs and other routine tests. They plummeted during the pandemic. The COVID testing was increasing, and ultimately COVID testing surpassed all of our routine testing. We were doing, as it says here, 5,000 tests a week. Incredible. And despite all these instruments, we didn't have enough throughput. So what did we do? We implemented, we've been talking about it for a while, we implemented pooling, and this saved our lives. I just want to talk about it briefly. Some of you know about how it works, but as it says here, faced with hardware limitations on the M2000, we could do about 3 runs per day on each. So we could do about 600 tests only. There was a limited supplies of reagents for Panther. We needed a new option, and we turned to pooling. What we did is we took aliquots from 5 different specimens, and we made a pooled specimen with all 5 specimens. What that does is it means you lower the sensitivity slightly of your method because now everybody's diluted with other people, but we went from a limit of detection from 10 to 50, which was still very sensitive and at least equivalent to the Panther and the Cepheid. The genius here is that if the pool is negative, we can report all 5 specimens as negative. If the pool is positive, we have to go back and run all 5 individual specimens to get the individual results. And what was difficult to comprehend at first and to explain to people, but I'll do it here a little bit, at a 2% positivity rate, and for the sake of argument, let's assume we were trying to do 1,000 specimens a day. We couldn't really do that many. but for the sake of this demonstration, with 2% positivity, 20 specimens would be positive. If we ran all of these as pools, we'd only have to run 200 pooled specimens because there's 5 in each pool. We'd only have 2 runs on the Abbott M2000. At a 2% positivity, 20 pools would be positive. We'd have to rerun all 5 specimens from each of those pools. That would be another 100 specimens. So the total number of specimens we'd have to run would be 200 plus 100. That would be just 3 runs on the M2000. So we could handle that pretty easily. At 5%, the same math tells us we'd have to do 450 specimens, 5 runs. When you get to 10% positivity, things are getting a little tight again because we could only do 6 runs a day. So this is where pooling doesn't work so well anymore if you have limited hardware. Another way to demonstrate that, because this happened to us, at a certain point, we ran out of enough reagent to confirm the individual pools on the Panther. So we had to do the pools and the individuals on the M2000. This 400 line represents the absolute maximum you could do on an M2000. Like I said, if you had no positivity, you could run 1,000 specimens a day on each one. You could get a lot of tests out. But as the positivity rate goes up, you start to get to the point where you're just backing the instrument up. And at about 8 to 10%, if we didn't have Panther for confirmations, we couldn't do any more tests. It all related to the positive rate. It works extremely well at low positive rates. And it got us through most of the summer and fall. So returning back to our timeline, so here we are in July, the pooling began, we were able to do all of this work. And at this point, you know, people were working very hard throughout the lab. We'll talk about that in a minute. But we were doing 5,000 to 6,000 specimens a day, tests a day. This dip here was for Labor Day weekend. Some of you will remember that on September 23rd or thereabouts, we hit our 100,000th test. And we had a little celebration in the conference room. It was a real milestone for us. We're not a large lab, we're not a small lab, but we really did an amazing job for a lab our size doing that many specimens. I'm going to change to this other diagram that you probably saw in our newsletter. Oops. But I think this summarizes the whole year. The columns here represent the daily volumes now of testing that we did, all the platforms we have. You can see that the peak volume was crazy here in the late fall. Early on, the positivity rate was as high as 30%. It came way down, you know, as various measures were in place. And we were in a very sweet part here because the positivity rate was low and we could handle this high volume of specimens. Then came the fall, the positivity rate went up, and that was a really tough time. And then mid to late January, the volumes went down again. The positivity rate has started to creep up, but we're really in good shape, basically, because we don't even need to pool anymore. We can get through the workload pretty easily. But this is a nice slide because it does give you a year-long overview of what's been going on. I added to this the fact that we are approaching 250,000 tests that we've done here at Tufts Medical Center. Pretty amazing. I wanted to spend a moment talking about variants because they're a very popular topic right now. As I said at the outset, most of the PCR assays that are being done for SARS-CoV-2 are multiplex. They target multiple targets in highly conserved regions. And since finding any one target translates to a positive result, variants will almost certainly be detected because the variants so far don't have mutations in more than one of these targeted regions. This is a very nice slide from UC Davis, and they were explaining why their assays were unaffected by variants. I've added an overlay here for the M2000. It detects this highly conserved area as well as this highly conserved area. So we're not going to miss variants because of that. Now, I mentioned earlier that if you have different colored complementary oligonucleotides, you can tell which target has lit up. The Abbott M2000 doesn't have different colors for their oligonucleotides, the labels. So we don't know which target lit up. But because we're looking for two of them, variants are considered to be not a problem, at least not so far. Any one target that amplifies will be detected as a positive. I wanted to finish by calling attention to the fact that, as we've said repeatedly, and we can't say often enough, this really was a team effort by everyone in our department. Let's start with CRA. I mean, the number of specimens they've been processing is truly mind-boggling. And they've worked very hard, and they did an exceptional job and continue to do an exceptional job. Microbiology has done all the initial processing. I don't want to scare them, but on 250,000 specimens, almost 250,000 specimens since a year ago. And that's something that we tend not to recognize, and we should. In addition to that, microbiology has been doing, excuse me, all the rapid Cepheid tests and Liat tests 24/7 for the last year. So kudos to them as well. The cross coverage across all the labs has been amazing. People from AP as well as CP have been helping out in the labs and with the associated things that needed to get done, which included this manufacturing facility that we developed for making viral transport medium. I mean, it's just incredible. Some of you saw Karen walking around with, you know, the cart and all the reagents, and I think they had to move one time and another time, and everybody's been helping with that. We could not have done all the tests that we did if we hadn't started manufacturing viral transport medium. A lot of labs had trouble. They didn't do it, but we did. So kudos to them as well. And all the people that put together and continue to put together assembling these kits. We hadn't put the kits together, we never would have got the specimens back to do the testing. So again, a lot of credit goes to a lot of people. There are so many people who are working overtime, who are working crazy shifts, whose lives have been upended from what they used to be. No one could have predicted what this whole pandemic would have looked like. So all of us appreciate what all of you have done. There's so much more. It would not have fit in 30 minutes. Nothing about this pandemic was easy, but throughout the year, everybody rose to every occasion that faced us. We provided incredibly accurate data, reliable service, turnaround times. I mean, it's been unbelievable, and everyone deserves a pat on the back, and no better time to recognize it than during Lab Week. So we have been, and remain an integral part of Tufts Medical Center's success in saving lives in this pandemic. And that's a lot more important than all the revenue we brought in. But remember, the revenue we brought in was critical to helping the medical center weather the financial storm. But the real important thing is how important it was to get these tests done in a timely fashion. I don't think there's any other lab that did a better job than us. We just did an amazing thing. So again, a huge thank you to all of you. We should celebrate Lab Week. Hopefully next year we'll be able to do it properly, but I want to thank Carla and the people that put together the celebration this week. But it's been a very difficult but special year, and a huge thank you to everybody. I'll stop there and answer any questions if there are, and we'll leave it at that.
Yeah, I do have a question for you, and that is, how you prepare, well, you weren't able to prepare the pandemic stroke all of us, but how did you get into to have those different platforms available? Did you have them already, or did you have to stock them up? And how did you diversify, or why didn't you stick to one platform that served you well and got like 4 of them? What was the advantage of how you did it?
Okay, so the M2000,
everything's just spot on, but how did that happen?
That's an excellent question, Ulrike. So we did have the M2000. We also had the Panther. We were using them for our other molecular tests. Abbott was the first, what had the first reagents that we could use. So Dr. Bogan implemented that test on the M2000. And we got the second M2000 because we were doing so much testing with Abbott. And Abbott was really unique in being able to provide reagent where a lot of other companies couldn't. We had the Panther, we validated their assay when it came out, and the Hologic people provided a second instrument for us for basically the same reason. They're making their money on the reagents. So we were able to use that. Cepheid was the same idea. It's not a high throughput instrument, can only do about 100 tests a day, but it's a rapid turnaround time. We never added extra capacity to that one because we could handle the number of rapid tests we wanted. So it was a combination of things. We couldn't afford we didn't know about, we got taken by surprise, during that early summer. So pooling was a faster strategy to increase our throughput than getting another instrument in and bringing it in and trying to validate on that. So that was that reason. We did propose getting another instrument that we ultimately got, the Alinity M, but the hospital refused to buy it for us. So that would have been a great thing to have. But we got an instrument in January finally, but that's how it went.
Mm-hmm.
I hope that answers the question.
Yeah, thank you very much. Mm-hmm.
Any other?
Yeah. Do you see how do you foresee the next half year? What do you expect to happen? Is there anything you can prognosticate? No.
None of us can make predictions. So one other question that's related to what you're asking is, are we stuck with these new instruments that we have? And the answer to that is no.
Yeah.
We're going to move a lot of our molecular testing onto the Alinity M. They have optimized, which is a whole other lecture, the testing that they do, so that instead of an 8-hour turnaround time on the M2000, which used to seem great for a molecular test, it was a 4-hour extraction and another 3-hour amplification. That assay is now a 2-hour assay. So from beginning to end, 2 hours. Also, the M2000 is a batch analyzer. We can only run one assay at a time. The Alinity M will let us run as many as 12 different molecular tests simultaneously at 1,000 different tubes a day. So the Alinity M's will be great for us, and we will retire the M2000s. The other things that are on the horizon, I think, are antibody testing, which hasn't, received much endorsement yet, but people have talked about it. And there's some interest potentially in antigen testing, high volume antigen testing. We can do those assays, but there's been no consensus either at our hospital alone or across Wellforce as to whether we should be doing those tests. But I don't know that we're ever going to see a big increase in volume again, unless there's some bad variant that comes, but we're ready for the next.
That's my next question. I don't want to occupy the conversation here, but I'm wondering if new variants come out, how are we prepared with our current assays or platforms? Can we create our own assays on them, or
no?
No,
these are not open platforms. We've talked about that, but I think the lesson, and this is an important thing, I'm glad you asked the question. It's a little bit beyond what we did here, but it's a great question. If you remember back to January, the CDC came out with its own assay, and they weren't letting the manufacturers, the diagnostics companies, come out with theirs. And their initial assay they took the World Health Organization assay with 2 targets. They added a 3rd target, and that initial assay was a disaster. And the United States lost a month because the CDC messed up, basically. Once they let the diagnostics companies get involved, they turned all these assays around so quickly, it was unbelievable. Yeah. These people are geniuses. I mean, they've got so many great scientists. So if there is another variant that comes out, my guess is that Abbott and Hologic and Cobas, Roche, they'll get something together pretty darn quickly, much more quickly than we can. The big problem was supply chain, and Abbott by far was, we were lucky. Honestly, we were very lucky that we had Abbott because they were the most reliable source of reagents.
So as you're saying that, do you think that we should get an open platform to be prepared ourselves, or would we not be able to implement anything as fast as the industry would come out?
Yes and yes. Yes, we'd love to get an open platform so that we could develop our own assays. But I think that in terms of having an assay for something like SARS-CoV-2 or 3, whatever it's going to be, we're going to rely on the manufacturers. Even the labs that have their own assays are basically have been relying on the big boys and girls, I should say, to be able to supply them. Yeah, so we'd love to have an open platform, but they're very expensive. But I know Ming would like us to get one. It's just hard to get, as you know, capital equipment around here.
Well, plus it's interesting because the application might be different from what we envision, right? Or not you envision, but some of us envision. It might not be for emergency preparedness. It might be for flexibility on other levels.
Yeah. But the question the hospital is always going to ask is, what's the return on investment, unfortunately? And I think you were at the conference the other day with Dr. Peak, which was really interesting to me about how the newborn screening things are working now on LCMS-MS with enzymology. Well, that's a different topic, I'm sorry. But we'd love to be able to have an open platform. And Dr. Zhao is interested in getting, digital droplet PCRs.
Yeah, but it might, in the end, not serve for emergency preparedness for the next pandemic, right? So putting it into the realistic perspective, what we would be using it for in the end, that's important too.
Yeah.
When setting priorities.
Yeah. Yeah.
Gary, I have a quick comment and question. I'm sorry I missed the first part of it, but I have only been following from the sidelines all the amazing things that have been going on in CP, and you guys have done a fantastic job, obviously, and I feel like in a way, you carry the weight of the hospital on your shoulders. Are you going on a publicity speaking tour? Are you going to go and spread the word about what the Department of Pathology has done for Tufts Medical Center? And I mean, it is Lab Week after all, but I think one of the things that we have in pathology is sometimes we have that role as being the we're behind
unheralded.
Yeah, the kind of unheralded efforts. So
yeah,
but we did so much. You guys did so much. I certainly hope that you're going to spread the word some more.
Well, that's an excellent point, Jeffrey. Yeah. But let me explain a couple things. One, a lot of labs have been doing, the same kind of work. Second, as hard as we've worked, when you hear what the clinicians have been dealing with, anything that we could do to support them was really important. And many of us in the department, have helped out clinically as well. I don't want to ignore that. So, a lot of people have done a lot of work. But more important is that since, I'd say at least the last 6 months, if not previous to that, there's a Wednesday meeting across WellForce of the ICU doctors, the infectious disease doctors, the senior leadership of WellForce, the whole senior chief nursing officers, just a group of 60 or 70 people that met every Wednesday evening. And they included the lab as part of that because we were so critical to their mission. And so I participated in those for the last 6 months or so. They're well aware of what we've done on a regular basis. They have thanked us. At last night's meeting, Helen Boucher actually knew about Lab Week, unprompted by me, and thanked all of us, as she does pretty much every week, for all the hard work that we've done. So the lab has been very publicly acknowledged at the highest levels across WellForce, and that's been really good for us. We have a very public face now. So I don't know that we're going to have I'm happy that we're known across WellForce. And I hope the labs at BMC and Beth Israel Deaconess and Brigham Women's are as well recognized there as we are here now. So good question. I'm glad you asked that.
I'm so happy to hear that, Gary. Well, thank you. I got to sign off, but thank you again.
All welcome. And again, you can tell your colleagues that I think this has been recorded, so if they missed it, they can see it. Thanks for all the great questions. Thanks for participating, and
Thank you.
back to work. And happy Lab Week.
Thank you, Dr. Horowitz.